Aloha judges, we are Team 4270B, the Crusaders from St. Louis School located in Honolulu, Hawaii. This is our 4th year as a middle school robotics team, and our vision is to use robotics to help our community here in Honolulu, Hawaii.
In times like this with the pandemic, automation is encouraged to reduce contact between people and objects. With this year's theme being technology, we wanted to create and model a smart home. A smart home is a home with automation, consisting of heating, lighting, and other electronics controlled by phone or computer. These smart homes can also be controlled autonomously.
With many homes nowadays, most people would have to manually turn off and on light switches, turn on a fan, and also contact the doorbell in order to ring it. A low-contact automated home would be a home that would turn off and on lights, heating systems, and even ring doorbells automatically.
For our model smart home, we wanted to use different sensors and peripherals that corresponded to what we needed our smart home to do. The peripherals that we used for this project are a temperature sensor, light sensor, push button, and LEDs. After learning and understanding about the sensors we'll be using, we started to 3D model our scaled down house. When it came to scaling, we had to scale down an average sized house to our 12-inch by 12-inch wooden board. We started by using the 3D model platform Tinkercad. The first step was building each individual wall section. We have 11 walls, 3 windows, 1 bar counter, and other furniture to point out which room is which. As we started to 3D print, we ran into a problem. Our 3D printers didn't have a big enough plane to print a whole section. Therefore, we printed different sections to fit in the 3D printer's build area. After we finished printing each section, we began to hot glue each house section onto the board.
After the completion of our house model, we used an Arduino and breadboard to test the functionality of the sensors and peripherals. The first sensor that we programmed was a temperature sensor, and the temperature sensor determines when to automatically turn the ceiling fan on. The second was the light sensor to help us determine when to automatically turn on the porch lights. The light sensor can also determine if it is day or night. Our last sensor was the push button, and this sensor would be the key to our doorbell because when the push button is pressed, our doorbell would ring. Our next step is to wire and solder the electronics on the model home. Everything functioned as planned, and this made us realize that as growing engineers, we can help and create ways to enhance our community. This is what our model home would be like in the end. It would also include more sensors like these. In this project, we got to see, learn, and understand how technologies are able to enhance our communities. Especially in this pandemic, creating an almost hands-free area would encourage the reopening of the world.
This has been Team 4270B with our project, The Contactless Home. We hope you enjoyed our presentation. Aloha!